Hi, Mr. Corsi here. In this question we're told the coordinates of these 3 points in three-dimensional space, A, B and C, and we're told that they're collinear. What collinear means is that these 3 points lie on the same straight line. Now we're not sure yet what these relative distances A to B and B to C are. In fact, that's what we're asked to find. We're asked to find the ratio in which B divides AC. But what we do know is the coordinates of these 3 points, -3, 4, -7, 5, T, 5, we don't know the y coordinate of the point B, and 7, 9, 8. So let's have a look at what we do when we travel from A to B, the components of that journey. Now somewhere there'll be an origin and position vectors, which just tells us what we have to do to get from the origin to each of these points. And the components of these position vectors will be identical to the coordinates of the points. And the basic result is that if we travel from A to B, then it's position vector of B minus position vector of A. Position vector of B, components are the same as the coordinates of the point. Position vector A, components are -3, 4, -7. So let's work this out. 5 minus -3, that's the x component, that'll be 5 plus 3, 8. The y component, t minus 4. 5 minus -7 is 12. So components of the journey travelling from A to B are 8, t minus 4 and 12. Let's now look at the journey from B to C, because we really want to compare these two journeys to try and find a ratio of the lengths. So journey from B to C will be position vector C minus position vector B. Components of position vector C will be 7, 9, 8, same as the coordinates of the point C. And components of position vector B, 5, T, 5. So the components that we're after, 7 minus 5 for the x component, 9 minus t, and 8 minus 5, which is 3. Now we would immediately see in comparing the x components, 8, 2, 8 is 4 times 2, and comparing the z components, 12, 3, 12 is 4 times 3. We do know that these are collinear. Since they're collinear, we know that we can express one of these journeys in terms of the other one. And in this case, we can see that AB is equal to 4 times BC. And that'll be true of the y components that we know nothing about yet. So AB is 4 times BC. So this diagram is not quite in the right proportions. We now know that from A to B is 4 times the distance from B to C. So this line will be 4 bits compared to 1 bit for this line. So we certainly now know that B divides AC, in the ratio 4 to 1. Now the order of these numbers is important. It's A to C, so we start with A, finish with C, 4 to 1, not 1 to 4. So that's first part A of this question. Let's now have a look at part B. We're asked to find that value of t, the missing y coordinate of the point B. So what we do know now is that the y component of AB will be 4 times the y component of BC. T minus 4 is 4 times 9 minus t. So we have a good old-fashioned equation to solve here. T minus 4, let's get rid of the brackets. 36 minus 4t, let's add 4t to both sides. We'll get 5t minus 4 equals 36. And let's add 4 to both sides. 5t equals 40. Divide both sides by 5. T equals 8. State the value of t. T is 8. Good double check that we've done everything okay. 8 minus 4 in here. Component is 4. 9 minus 8. Component is 1. And you can see that 1 multiplied by 4 does give us that 4. So that fits in with the fact that each of these components on AB is 4 times the corresponding components on BC. So that's question 5. So that's Mr. Carsey signing out, and thanks for watching this video.